Okay, and now let's try something together. I suggest a little valuation exercise to understand whether it makes sense to buy an electric car over a gasoline car. For that, we are opening Excel. And here's already pre-built model for running Monte Carlo simulation and simulation decomposition with some macros and VB there. Let's get first estimates for an electric car. Let's assume its price would be $40,000. Our mileage per year, let's say around 10,000, and of course we'll be playing with these numbers in the simulation. Then electricity consumption, I've checked, it's about 20 kilowatt hours per 100 kilometers. Then electricity price, of course it depends on where you are, and still it varies. So let's assume it's $50 per megawatt hour, and so we can now calculate the electricity cost per year, and it's going to be the mileage multiplied by the electricity consumption divided by 100 kilometers, and then the electricity price divided by 1000 to get the megawatts to kilowatts. And we get $100 per year. Then let's assume some maintenance costs, something like $100 per year, and there would be zero CO2 tax. And from these assumptions now we can calculate the costs of owning the car. And let's say it would be for 5 years, and we assume no discounting for simplicity. So we get the car price plus 5 multiplied by the sum of electricity cost, maintenance cost, and the tax. Okay, and we get $41,000. Now let's do the same briefly for the gasoline car. So let's assume it's a bit cheaper. 35,000 euros, then mileage would be the same. Then fuel consumption, not electricity, fuel consumption would be, let's say, 5 liters per 100 kilometers, then a small car. Then the fuel price, well, let's say around 2, and then the overall fuel cost would be actually, no, it wouldn't be the same. It would be mileage multiplied by the consumption divided by 100 and multiplied by the fuel price. Yep. And then maintenance costs, let's assume $300 per year, and CO2 tax, some of it, $250 per year. And the overall price, we just copy paste it, would be $42,750. And let's calculate the benefit of getting an electric car over a gasoline car. It would be simply this one minus this one. Yep, and in this case, with no uncertainty or variation in the model, it's about $2,000, which is nice. But what we want to do, we want to check how this benefit would behave for variation of these factors, and maybe we'll adjust our choice somehow based on that. So we go to this tab, Monte Carlo, and we get first our inputs here that we want to vary or that we want to have uncertainty inside. So let's have it here, car price. Then mileage, and then electricity price. That is safe to assume that those things will change. So car price for the electric vehicle, let's assume would be changing from $30,000 to $50,000. And here the random number is generated using the uniform distribution. But if you don't want a uniform, you can of course model whatever you like in here. It's just Excel. Then mileage in between, let's say, 7,000 to 20,000, and electricity price from 30 to 70. And now what we need to do in order to run the Monte Carlo simulation, we need to connect these random values to the model itself, so it feeds it to the calculation and gets the output from there. So the car price, here it is linked to this value, then the mileage to this one, and it would automatically change the mileage for the gasoline car, and then the electricity cost would be electricity price, would get a number from here. And now in the outcome, so we need to tell the model practically what we need to record as the output, and the output would be our benefit, and it is here. Yep. And now every time the calculation happens, the new random values are generated, they are fed to the model, and the output is new. And based on that, we can run Monte Carlo simulation. Here it is. And that would be our graph. That is not very informative, except that we have quite a variation of benefit, and it can be actually better to get a gasoline car for our assumptions, for some conditions which we don't know which are they. So now let's perform the simulation decomposition. So I suggest we just use these two factors, car price and the mileage. And well, at least in this model, it automatically takes the first three variables for decomposition. The car price, we can divide it by two different states. The one cheaper than we wanted, there is 40,000 euros, and more expensive than that. And here we specify the numerical threshold, but minimum and maximum undefined based on the min-max defined in the in here. And then mileage, let's divide it into three different states. Let's say from 7 to 10,000, we'll call it tiny. Then from 10,000 to 15,000, we'll call it expected. And from 15,000 to 20,000, let's call it excessive. And now we can run simulation decomposition and update the chart. And here is our result. We have the green colors for cheaper prices of the car and violet for the more expensive ones. And then we have shades of colors, of both colors, for different levels of mileage. So based on this analytics, we can say that the benefit is positive. It's more beneficial financially to own an electric vehicle if we manage to get it 40,000 euros or cheaper than that. And if we get it more expensive, then it's quite high probability that we ending up paying more than if we own the gasoline car. But hey, it's not all about the money, right? And what we can say generically about the model behavior in this case, well, the car price is clearly here an influential factor, and it divides the distribution into two clear different parts, almost vertically. But then the mileage having all other uncertainties, which is electricity price in there, right? It's not that influential. Still there is some shift, but practically scenarios lie on top of each other. So the influence of that factor gets kind of diluted in the electricity price uncertainty, and the car price is the one to take care of in order to steer the result into a desired range. So this is how the Excel can be used for Monte Carlo simulation and simulation decomposition. It is yours. Go ahead. A couple of suggestions only. When you play with decomposition, try different factors, see how you can try them one by one. You can check then how they influence your outcome in the presence of all other uncertainties. They might be not that influential after all. Definitely try combinations of different factors. You'll be able to see if there are any interactions, if there are any synergies in your model. And of course, the more complex the model is, the more interesting things you'll see with SimDec and all these interactions inside. Then colors. If you just randomly choose the colors, it's going to be a mess. So I would suggest using the most influential factor first and using the main different colors for the states of this main factor. And all the others can go easily with the shades of the main color. And then as in here, you will get quite a consistent and visually intuitive picture. If you decide to try simulation decomposition in your practices for your decision-making problems, please let me know. I was so curious to see the results and maybe help you develop them any further. This approach is my academic baby, and I would love to know if it really manages to help people make better decisions. Thank you for your attention. I hope you enjoyed this talk.